So we see that a small change in t results in a small change in x, which contributes to a small change in z, and a small change in t also contributes or causes a small change in y, which in turn causes an additional change in the value of z. So we can make some statements. If t changes by small delta t, then by how much does x change? Well, x changes by dx dt times your change in t. dx dt we're going to write just as x prime of t, the derivative of x with respect to t. So x prime of t delta t is going to be equivalent to this expression, the same as this expression with slightly different notation, and that's going to give us a small change in x. And y changes by about y prime of t delta t, and that's of course very similar to this expression. Now, what does that do to z? Well, z then has to change by an amount that we'll call delta z, and that's got to be approximately equal to, well, fx times the change in x plus fy times the change in y. Again, something we're pretty familiar with by now. Now, what's the change in x? The change in x is x prime of t dt. That's easy enough to understand. So here's our x prime times delta t. Now, I didn't write the x prime of t. I suppressed that part of the notation, but we understand that x prime means x prime of t means dx dt. If we look at this expression, of course, we're going to have a similar expression for y. What's fx? Well, fx is the rate of change of x with respect to x. That's how fast f changes with respect to a change in x. And what we have here is the rate of change of x with respect to t and the change in t. So this is our change in x, and we multiply that by the rate of change of f with respect to x, and we get a change in f due to the effect of a change in t on the value of x. Similar term over here. We have fy, which is the rate of change of f with respect to y, multiplied by y prime delta t. Y prime is the rate of change of y with respect to t, and delta t is the change in t. So this is our change in y. Multiply our change in y by our rate of change of f with respect to y, and we get the contribution due to the change in y that results from the change in t, the contribution to the change in the value of z. Now that might or might not sound a little complicated, but if we understand the nature of a rate of change and how derivatives express rates of change, then it's a fairly straightforward idea. It just takes a little sorting out. Looks complicated, but we break it down piece by piece and then build it back up, and we understand what's going on. Now, if we take this, delta z is approximately equal to this, that is, a small change delta t results in a change delta z. So what's our delta z over delta t? Well, that's approximately then equal to our fx times x prime plus our fy times y prime, because we simply take delta z equal to all this. We can factor out the delta t divided into delta z. So delta z over delta t is what's left over after we've factored